multiply and simplify radicals. So to start off on the right, I have numbers 2 through 10 squared, just so I can remind myself what numbers have that perfect square root that I'm going to want to try to use whenever possible. So this first one, well, what we can do is we have the two things multiplied together. We can just go ahead and put those all under one giant radical if we want. So let's go ahead and do that. So I'm going to have 4, and then I have the square root of 75 times 12. So that 75 and the 12 would give me a 900. This one just coincidentally worked out to be a pretty number, right? Typically, numbers over 800, I'm probably not going to know off the top of my head the square root that I'm going to want to use. But this one is a nice, pretty number because I can actually use two of them, right? I can use 100, stands out to me first because that would be a 10. And then that 9 would be what was left over. So what I would do is I like to draw it like this, is I circle it and I say I'm going to pull that out so I can kind of visualize it coming out of the radical. So square root of 100 would give me that 10. And then same thing with the 9, pull that out, I get a 3. And then 4 times 10 times 3, I get 120. Okay, so they won't always turn out to be pretty like that. They probably won't, right? So I'm going to show you a second way to do that same problem. Let's just break it down each piece at a time. So I have my 4. So the 75, remember I'm trying to use those numbers that are in my green box over here on the right. And it looks like a 25 I could use. So 75 is 25 times 3. And then I have the square root of 12. I want to use one of those numbers. I see the 4, so I'm going to go with a 4 times 3. Now let's go ahead and bring these guys out front. So I have my 25, pops out, that's really a 5. I'm left with the square root of 3. I'm not going to write that quite yet just because it kind of confuses me. And I don't want to confuse anybody. So hopefully this way doesn't confuse you. Is I'm actually going to go grab that 4 right now so that I can have all my good whole numbers right out front. So when I pull that 4 out, that's a 2. And then I'm left with that first square root of 3 here, and then the second square root of 3 here. So I'm going to have square root of 3 and then square root of 3. So if I go through and multiply that 4 times 5 times 2, I get 40. And then here we have the square root of 3 times the square root of 3, which is just going to give you 3. If you aren't quite sure why that is, though, is you would just take the 3 times the 3, which would then be the square root of 9. And then from there, you can see that square root of 9 is 3. So you would multiply that by the 40 and get 120. Okay, so sometimes you actually won't be able to break them down like that. Okay, so the 75 and the 12, those broke down nicely. But if you look at this final example that I have, the 2 and the 8, I can't break that down, right? Because there's no perfect squares that I can use to get those numbers. So some students think, oh, I'm done because I can't break those parts down. But that's actually not true because you can go ahead and multiply those together and then simplify. So I'm going to have my 2 times the square root of, inside of here, that's 2 times 8, right? So now I have 2 times the square root of 16. And can I reduce that? Yes, I can, because square root of 16, that would give me 4. So really I'd have 2 times 4, which equals 8. All right, I hope that helped you out. I will see you later.